engineering, and welcome to lecture 2 of civil engineering, math things we need to know. So first we're going to talk about some SI prefix conversions. Well, basically this whole lecture is about how to make your own conversion factors, right? Or find them, or like pull them out of the information that you're given, right? If we think about here, right, in this lecture, right, we had a whole bunch of conversion factors given to us, right? These are things we're already familiar with, things that we already know, right? Now we're going to talk about how can we use other things to pull out conversion factors, right? So these should be kind of familiar. The SI prefix table is something that you guys talk a little bit about in 8th grade physical science. And here we're just going to talk about how to set these problems up, well, how to use this table, and how to set these problems up in dimensional analysis format, which again shows that you understand the units and that you can convey that understanding to other people, and that somebody else could double check your work quickly and easily, right, to make sure that you did it correctly. So first, let's look at our prefix conversions. So this table is our prefix table, right? Here is where our base unit would go. And our base unit could be any standard unit, like for example, meters or grams or seconds, and there are others, and we'll stop there for now, right? And then the rest of these, right, are our units, right? So we have kilo, where the abbreviation is a K. We have mega, where the abbreviation is an M. Giga is a G. Tera is a T, right? Milli is a lowercase m. Micro is a lowercase mu. Nano is an N. Pico is a P. Femto is an F. Atto is an A. And all these do is they relate how many decimal places difference there are between what you have and what you're trying to convert to, right? So the base unit is like saying 1 times 10 to the 0. Don't move the decimal at all. It is where it belongs, right? If I wanted to convert to kilo, that relationship is 1 times 10 to the 3rd. Mega's relationship is 1 times 10 to the 6th. Giga is 1 times 10 to the 9th. And this is 1 times 10 to the 12th, right? You'll see that every line represents the moving of 3 decimal places, right? Where these are units that are getting bigger, right? If we go in the other direction, milli is 1 times 10 to the 3rd places smaller. 1 times 10 to the 6th, 1 times 10 to the 9th, 1 times 10 to the 12th, 1 times 10 to the 15th, and 1 times 10 to the 18th. And this is places smaller, right? So if we take a look at this, right, this allows us to pull out relationships between units. Let's go ahead and try to solve some problems. So this is to convert 5 meters to megameters. This is my given, and I'm trying to convert to megameters, which means that I need to write a conversion factor between meters and megameters. So step 1 is always going to be find the bigger unit. Step 1 is always going to be find the bigger unit. So let's go find the bigger unit. The bigger unit is megameters, right? So let's go find them, right? Megameters are right here, and meters are here at the base unit, right? Mega is the bigger unit. That gets a 1. And the exponent goes with the smaller piece, so 1 times 10 to the 6th. And what that says is there are 1 million meters in 1 megameter. Yes, does that make sense, right? So there's a boatload of meters equal to 1 megameter, because a megameter is a big unit of measure. So then we just start with our given right here. So 5 meters, put it over 1 for clean bookkeeping, right? And then here we're just going to put meters and megameters, because I know that's where the pieces need to go. And then I fill in, right? This goes with my meter, and the 1 goes with my megameter. Meters cancel, and then I just have to do the work, which is 5 times 1 over 1 times 10 to the 6th megameters, right? And this is how to do exponent-based math is something that I think is introduced in Algebra 1. It gets reviewed in Algebra 2. If you feel like your mastery of exponent math is a little bit fuzzy, drop by and see me, and we can talk through how to do that. But really, if you don't remember off the top of your head, you can type it into your calculator, and that would be okay. So entering this into your calculator, you'd start by typing in 5 divided by 1e6, where 1e6 means 1 times 10 to the 6th. Alternatively, you can type in 5 divided by 1 times 10 to the 6th, like the literal version. It'll give you a fraction, but you can go ahead and take control and the minus, control negative, and that's going to bring your answer back down, and control enter will go ahead and give you the decimal answer. And those are your options for typing this into your calculator. But we would get 5 times 10 to the negative 6th megameters, right? Which makes sense because we are converting to a much smaller, we are converting from something small to something big, right? So again, a megameter is like this. And a megameter gets broken into boatload of meters, right? So then that makes sense. All right. Next up, it says that we are going to convert meters to micrometers, right? So that means we got to come up with a relationship between meters and micrometers. So just like last time, we will go to the table and find, that's fine. We've got the base unit right here, and we need to find micro, which is down here. So which of those is bigger? Because step 1 is find the bigger unit. The bigger unit is meters in this case. The exponent is 10 to the 6th. So that this says is there are 1 million micrometers in 1 meter. So I'm going to take my 5 meters, and again, I know meters down here, micrometers up here. And I'm going to fill it in. The 1 goes with the meter. 1 times 10 to the 6th goes up here. Meters cancel, and I end up with 5 times 10 to the 6th micrometers as my final answer. Yes? All right. Finally, we have our last problem that says we're going to convert 25 millimeters to nanometers. So same thing, millimeters, nanometers, and then I go find it on my chart. So let's see, millimeters are here, nanometers are here. So step 1 is the same. Which of those is the bigger unit? Right, millimeters are bigger, and then I need to find how many decimal places are between them. That's not necessarily, we wouldn't say adding or subtracting, because then we have to put in a bunch of qualifiers. What we're going to do is we're going to find out how many places are between them. If this is 10 to the 3rd, we go 3 decimal places to get to the 10 to the 6th. And then we go 3 more decimal places to get to 10 to the 9th. So that means that there are 1 times 10 to the 6th places between them. Or 1 million nanometers make up 1 millimeter, right? So 25 millimeters over 1. We know millimeters needs to go here, nanometers go up here. And again, we just fill in our pieces of information. This cancels, and I end up with 25 times 10 to the 6th nanometers, which then we would scooch that over to put it into proper scientific notation. All right. Next up, oh no, here we have word problems. In a word problem, it works the same way. So here we looked at this table and pulled out the conversion factors, but we can also read a problem and pull out conversion factors. So let's try. It says that light travels at a speed of 3 times 10 to the 8th meters per second. Every time, every single time, all the time, you hear the word per really means equals. To reiterate, per means equals. So what that means is this is a conversion factor. So I know that 3 times 10 to the 8th meters are equal to 1 second, right? And then let's think to ourselves, what is meters a measure of? Right, meters measures distance, and seconds measures time, which means that I have just been given a conversion factor between distance and time. All right. The question goes on to ask, how long does it take, so I'm looking for time, for signals to go from the International Space Station to Earth? It being the International Space Station, orbits at an average distance of 254 miles above the Earth. And I'm given a distance, and I'd like to know about time. So that means, wow, thank goodness we have a conversion factor. So we would take our 254 miles, and then we would try to use this conversion factor, and what do we notice? Correct. The conversion factor is in meters. My given is in miles. But can I convert miles to meters? Yes, absolutely. So we're going to go back, and we learned that miles, we know that 1 kilometer is equal to 0.6214 miles, right? So 1 kilometer is equal to 0.6214 miles. I also happen to know, based on this slide, that kilo and the base unit have a 10 to the third relationship, kilo being the largest of those, right? They're larger of those, so 1 kilometer is equal to 10 to the third meters, right? So what can I write in here? Right, I could even like simplify this even more, right? I could say 0.6214 miles is equal to 10 to the third meters. Yes, do you see that? How we've just taken these two? And if 1 kilometer is equal to both of those things, then both of those things are also equal to each other, right? Which means that that cancels, right? And here, well, for the math anyway, we have 254. And by 10 to the third, I mean 1 times 10 to the third, right? Times 1 times 10 to the third over 0.6214 meters, right? So if we go ahead and get an answer here, this equals 408754 meters. So if we bring that down here, 408754 meters. Now I can use my conversion factor of 3 times 10 to the 8th meters are equal to 1 second, and those cancel, and that gives us this many seconds. So incredibly fast, right? Which makes sense because that's not very far from Earth, right? And it makes sense because information is constantly being exchanged between the space station and Earth, that it travels pretty quickly, right? Next up, we've got a problem about aluminum. So it says aluminum has a density of this, right? 2.7 grams per centimeter cubed, right? So again, every time we see something either written with that slash or just in the text of a problem, because that's what I should have put one of those in here and I didn't, but no worries, there's one coming in the next one. So 2.7 grams are equal to 1 centimeter cubed, right? And then some of you might say, but we did density before and I can just use that equation, D equals M over V. Well, true, right? That gives you the right answer, but sometimes you mess up what should be divided or multiplied. 2, that doesn't show any mastery of units, right? It doesn't show that you understand what's happening. It just shows that you've memorized a formula and you're just moving the pieces around. And that's not terribly helpful, especially if you're encountering something that's different or new, right? This method is going to allow you to take apart almost any problem that's composed of units and be able to figure out how to solve it. For example, in the next lecture and in class next period, right? Okay, so anyway, we have our relationship, 2.7 grams equals 1 centimeter cubed. This is a relationship between mass and volume, right? It relates those two quantities. If we continue reading, it says, what is the mass of a cube? So I would like to know about mass of a cube of aluminum measuring 3 centimeters on each side. So if I know that I have a cube of aluminum that measures 3 centimeters on each side, so 3 centimeters by 3 centimeters by 3 centimeters. What do I really know? Right, I know that the volume of the cube, right, is 3 centimeters times 3 centimeters times 3 centimeters, right? Which is going to give us what? Right, 27 centimeters cubed, right? Because if I take centimeter times centimeter times centimeter, I get centimeters cubed. Now, I can use this relationship, right? Centimeters cubed goes down here, grams goes up here, which means that the 1 goes down here, and the 2.7 goes up here. Centimeters cubed cancels, and I get 72.9 grams as my final answer. Ta-da! All right, practice. I promise that practice makes it easier. And in the next lecture, we're going to talk through a giant problem that has a whole bunch of different conversions in there, and a lot of them are going to be new. But the point is that if we understand this method, right, where we can look at units, pull out conversions, and write them out and work through them, right, it's going to get easy. And again, if there's anything here that stumps you, make sure you come see me sooner than later and ask some questions so we can try to clarify things for you. All right, thank you for listening. Be good, and I will see you soon. Bye.